We are delighted that on this August occasion, we have with us our Honorable Chief Guest, Professor Abhay Karandikar, Secretary, Department of Science and Technology, Government of India. An esteemed engineer, educator, and administrator, Professor Abhay Karandikar has been serving as Secretary of the Department of Science and Technology, Government of India, since October 2023. Formerly the director of IIT Kanpur and a key academic leader at IIT Bombay, he has played a pivotal role in shaping India's tech ecosystem. A founding member of Telecom Standards Development Society of India, he was honored with the IEEE Standards Medallion in 2016 for his work in telecom standards and policy. His career is marked by a deep commitment to innovation, scientific progress, and national technological advancement. Sir, we are eager to hear your perspectives on Dhātu and its potential to impact education.
Thank you very much, Dr. H.S. Nagaraja, Professor Balram, Dr. Tejaswini, Mr. Prahlad, Professor Narhari, all the distinguished guests, advisory board members of Prayoga Institute, and all the members of this unique experiment, as it is called, and as I think Dr. Tejaswini mentioned, that it is no longer an experiment but is now maturing into an institution. So my heartiest congratulations for making this experiment extremely successful. I'm delighted to see that through your various activities, the foundation has established a commendable legacy in driving innovations in educational research and setting up really a model for the entire country to follow in school educations. Particularly it is in the area of STEM educations, and today, for example, more especially in the mathematics. As a matter of fact, as you know that recent national surveys and carried out at various levels have shown that more than 80% of the students in our schools at the levels of 7th and 10th, they experience some kind of fear and anxiety towards the mathematics. And this is somewhat distressing to note in a country like India, where mathematics was really the foundation, centuries ago. And, look at the pioneering work done by Aryabhatta, who introduced really the sophisticated methods for solving quadratic equations, calculating square and cube roots, and even approximating the pi with reasonable accuracy. And as you know that Aryabhatta also proposed a heliocentric model for planetary motions using trigonometric methods. So we have the legacy of Aryabhatta, we have the legacy of Brahmagupta, and not only before that, even if you look at the Indus Valley civilizations, that has demonstrated a significant mathematical thinking through very precise urban planning, and more importantly, standardized weights and measures which were there, and finally in the geometric designs that was there in the town planning and architecture, that demonstrated a deep conceptual understanding of the mathematics when rest of the world was really grappling with the scientific traditions. And therefore it is somewhat of a great concern that in our country school children are actually having some kind of a fear or anxiety. Not only that, in our school educations, particularly at the high school level, we have introduced for years we have introduced some kind of a system where after the primary or secondary school, for high schools, you either choose mathematics or you choose biology. And this division actually created two sets of students. one who were devoid of complete mathematics educations were only learning biology, and one, who were learning mathematics but did not know anything about the life sciences and the biology. And as you know today, that all research which is happening is more and more at the intersection of all the scientific disciplines. There is a significant amount of mathematics now being used in biology as well. So even those who want to go, for example, and become a biologist, or they want to become life scientists, they need to know a significant amount of mathematics. Also, the significant advancements that are happening in the technology world, particularly in the area of artificial intelligence and machine learning, the foundations is really, the core foundation is really the mathematical algorithms. Finally, I think even in the upcoming areas like quantum technologies or quantum computing, and more recently like cryptography or quantum cryptography, the foundation remains the mathematical learning. So as was mentioned by several speakers, particularly, of course, Mr. Prahlad mentioned about Indian Institute of Science Bangalore, but I must say that since I studied in IIT Kanpur has also some very wonderful tradition of teaching mathematics, particularly in the electrical engineering. And I myself, although I did my PhD in computer networking area, many times it was told to me that for me, a packet is a point on the Poisson line. So that was, a packet in the computer networking. Until, I really blended the mathematical conceptual understanding with the networking protocols, and finally, of course, in the wireless networkings. Now, one problem that remains in our country is, of course, the lack of excellent and outstanding teachers who can make the subject interesting. But another problem also remains, particularly at the school level, for the students to connect what they are learning with what applications and impact this study is likely to have. And therefore, this disconnect is actually creates some kind of a fear in the worst case, and some kind of a cynicism at the best case, where students think that they seem to be learning only for the sake of learning, and this kind of a learning is not likely to have any applications either in practice or in their life at all. In fact, this is something which not only is prevalent in the school educations, but also in college and even at the engineering education, where it is very unclear many times to the students that what is being really taught is actually having a lot of impact, is going to have a lot of impact later on in their career, whether they go for professional engineering or whether they go for any other field. So I think this connection, that many of these foundational principles form really the foundations and the basis of the entire education system, is something lacking, which actually is required by the teachers for motivating the students. As I think was also mentioned, that in a country of our size and scale, given the large populations and also given the large number of students, it is extremely important to have the technology-enabled learning. And I should say that very little work has been done in our country in the technology-enabled learning. Of course, we have used online teaching programs and the video lectures and so on effectively, but that is actually not just sufficient for the technology enabled learning. In fact, in order to get a classroom effect, sometimes as a teacher, I know that when I'm teaching in a class, by looking at the faces, I can determine that what I'm teaching is getting absorbed by the students or not, and then I can appropriately modulate or reteach the concepts if I come to know, or I can ask the question and then get to know. But many times in the technology enabled learning, where it is not possible to get the effect of a classroom teaching, I think some extensive research is required to be done in terms of an online teaching, how to create modern tools, including the use of techniques of artificial intelligence, AI, etc., to see that we can create an impact of a classroom teaching in a technology enabled learning. So in this context, I would really urge Prayoga to do some kind of an experiment in this area to see that how we can effectively use the modern technologies to scale the education, not in terms of providing access, but also in terms of creating an effect where the learners are feeling as if they are learning in a way they would have learned if they had gotten a one-to-one connect. And I think that is really a difficult and a challenging problem in the area of education research, and I would feel that not much efforts have been paid, and this can be done only in a country like India, where I think Mr. Prahlad gave an example of just to see what is the size of the problems that we are talking, that this can make a significant and profound impact. Finally, I think I would like to congratulate the Prayoga team for adopting a very innovative method and a platform like Dhātu. I hope that this platform can bring a bold new paradigm shift to mathematics education, which can blend the tradition, technology, and also its relevance for the students. My apologies, I was a bit late, and since I saw that the presentation of Professor Ullman only towards the end, but I believe that these kind of techniques will enable the students for getting the insights maybe in algebra or calculus or geometry, and I hope that the student will be able to use this platform with ease and use cases, and I think this institute can use this platform to organize some kind of a maths challenge or hackathons as well, in order to popularize these techniques and make it available to a larger population. Finally, I should say that the reforms in the school education is incomplete without keeping the teacher in mind, because I think the teacher is the most important element in any education system, whether it is in the school or whether it is in the university, and therefore I think we have to not only train the teachers in pedagogy and in conceptual understandings, but also in terms of providing some kind of a soft skills which involves motivating the students otherwise also in a off-class fashion, so that the students can get enthusiastic and passionate about learning. Because unless the students are passionate and enthusiastic, the subject alone will not be sufficient. And therefore, it is really very important for training the teachers in making sure that they can arouse some kind of a curiosity in the students, a curiosity-driven teaching, and motivational learning will actually enable to provide an impactful education. Finally, I would say that the unveiling of this Dhātu platform is not just the launch of a new educational platform, but I hope it becomes the beginning of a movement which can be scaled to make a much larger impact in the education systems in our country. This journey requires all of us, the educators, the scientists, the policymakers, the teachers and students to come together. As the Secretary of the Department of Science and Technology, although our department mostly focuses on funding transformative R&D at university and institutions level, in fact, the Department of Science and Technology is one of the largest extramural funding agency in the country today. We have about 60 to 70% of the extramural funding comes from the Department of Science and Technology in our academic institutions. But we do have programs which work at the level of how we can improve the science education in schools, colleges, and universities. And we would be really happy to see that how very unique initiatives which are carried out in different parts of the country can be scaled to make a larger impact nationwide. So thank you once again for making me a part of this journey. I wish you all the best, and I hope through these small initiatives taken throughout the country, with these drops can come together, and we can make our nation a very strong nation in mathematics, which what it used to be centuries ago. Thank you.